I'm going to share a screen for y'all. And this file I put in Blackboard under course content for the 5th week. So let me let one in real quick. So y'all should be seeing a page with 7 graphs on it. These are what we call the basic graphs. So the first one is what we call the identity function, y equals x. So the identity means if x is 1, y is 1, x is 2, y is 2, and so on. Second graph is the squaring function, y equals x squared. So you can see that's a parabola we've been already graphing. Next is the square root function, y equals square root of x. After that, the cubing function, y equals x cubed. So the cubes are the ones that make the sort of squiggly line going uphill left to right. Let's see, the 5th one down here is the cube root. We got the reciprocal function, y equals 1 over x. And see, on that reciprocal, see how it goes to the left and to the right, but it does not cross over that y-axis. Remember, it cannot cross over the y-axis because if you put a 0 in for that x, it makes it undefined. So when graphs are undefined, that's sort of what they'll do. And we'll look at them more towards the, I think it's in the 3rd test material, might be at the end of the 2nd. And then last graph on here is the absolute value function. And we've already messed with the absolute value. All right, so you want to recall these 7 graphs. So if you need to take a picture of that, screenshot that, you can download it from Blackboard. Like I said, it's in Blackboard under course content for the 5th week. Although we're on the 6th week, it's in the 5th week material because remember I missed a day, so this was already set up in that 5th week, okay? So let me go, we're going to take these graphs, we're going to move them up, down, we're going to move them left and right, and we're going to reflect them over the x-axis. So I'm going to go to my pad so we can take notes on this. And what I'm going to do, I'm going to work the problems in the math lab so that y'all see how to graph these, okay? All right, y'all, so 7.2 transformations. So there's only 3 transformations we're worried about. The first transformation is what we call a vertical shift. So remember, my vertical shift to go up or down. So to get graphs of functions to move up or down, y equals the function plus or minus b. So if this was the x squared function, this would be y equals x squared, and then plus or minus whatever number I put here. So if this number is positive, then the graph moves up. Okay, so an example of that would be y equals x squared plus 3. This would take the basic graph of the x squared and it would move it up 3 units. So this would move up 3 units. Now, if this number at the end is negative, so if my b is negative, then my graph will move down. So an example of a graph moving down could be y equals cube root of x minus 4. So if I take my function and I subtract 4 from it, this will move down 4 units. Okay, so up if b is positive, down if b is negative. So now my next shift will be left or right. So we call that a horizontal shift. So a horizontal shift will come in this form. Y equals f of x plus or minus d. So notice, I'm adding and subtracting, but I'm adding and subtracting to my x value. I'm not adding or subtracting to the function value, okay? So I'm actually changing the x's that are being evaluated. All right, let me let one in real quick. So now this one, the horizontal shift is sort of backwards what you think. So I got two cases. If the d is positive, if the d is positive, so if I'm adding to my x that's being evaluated, if it's positive, this will move left. So it's sort of opposite what you think, but when you add to the x that's being evaluated, it'll move it left. And if the d is negative, then it's going to move my graph to the right. So I'll show you two examples of this real quick. So what if I did my x squared? So to change it, to make it go left or right, y equals x plus 3 squared. So notice, it's not an x squared now, it's an x plus 3 squared. By adding 3, before I square it, that's going to move my graph left 3 units. Likewise, if I take a function and subtract, so if y equals the square root of something like x minus 5, so notice this is all under the radical. In radicals, we sort of treat them like parentheses when we're doing order of operations. So if it's under that radical, it's affecting the x. So by adding 5 to my x before I do the square root, this will move my graph right 5 units. Okay, so at the end of the function, positive was up, negative was down. If we attack the x's inside the function, adding is left, subtracting is right. All right, so the last transformation we'll look at is called a reflecting. So we're reflecting over the x-axis. So remember, x-axis would be taking a graph and flipping it over it. So to get that, we would have y equals negative f of x. So like a parabola, if all of our values were positive, by putting that negative in front, it takes all those y values and makes them negative. So it's going to sort of flip our graph over. All right, so an example of that, y equals negative x to the third. So all we do to reflect that x-axis is put a negative in front of our function. So this will reflect the graph of x to the third over the x-axis. Now, MATLAB's going to have stuff about the y-axis, but in this section, we're not reflecting anything over the y-axis, okay? We'll do that kind of stuff. I think it's toward the end of the third material. Might even be on the fourth test material. So y'all remember these three moves we're going to do: vertical, horizontal, and reflect over the x-axis. So what I'm going to do is we're now going to go and work these problems in MATLAB so that y'all know how to actually graph these, okay? All right, so I'm switching this over to MATLAB. All right, so this wants me to describe how the given function can be obtained from one of the basic graphs. So I see that exponent 2 on this. So of the 7 basic graphs, this has to be the x squared graph, the squaring graph, okay? So now we need to know what's that plus 3 doing to my graph when it's being added to the x that's being squared. So y'all have a guess on that.
Moving the units B.
So let's see, what's B say? Shift the graph 3 units to the left. There you go. Remember, if it's inside parentheses and we add, we know it's going to shift it to the left. So click B, and then you got to actually tell it what was my basic graph. And that would be what, my x squared graph. So we would put our x and then put our exponent 2 on that. So on this one, you got to tell it what the basic graph was and then the move. Now we're going to check this answer, then graph it. So here's the trick on this. You got to click on enlarge graph. That's going to bring open a box for you. So from the chart, we know that the x squared graphs made the U-shaped parabola. So you click on the x squared tool. Once you click on the tool, you go anywhere inside that graph and click it. Well, let me get my tool. I don't guess I clicked it. So there it is. Anywhere in here, when you click it, it's going to put the graph in the center like the basic graph would be. And you see this little box that popped open? You don't have to worry about the vertical stretch and shrink and the horizontal stretch and shrink. What you got to worry about is the vertical shift down here, the horizontal shift, and under that one on the left, reflect over the x-axis. We're not going to have any problems, like I said, that reflect over the y. So since you said this graph went 3 left, we got to click on the little tab on horizontal shift and move it left 3 units. Once you move it left 3 units on that, look at my graph. My graph is not in the center no more. It moved over left 3 units. So y'all at that point, since that was the only move, we would hit save and then check your answer. So it's not bad. Now the next one I think is, let's see. This is the identity graph. G of x equals x minus 2. So since that's just a single x, we know that's our identity graph. So what did the negative 2 do to that graph? And y'all, one thing to notice on this.
Shift down.
Yeah, it's going to shift it down to, because it's not in parentheses. So it's going to shift it down 2 units. So it looks like we're going with C. And then in the box, this would be the y equals x. Now, y'all, this one is the straight line, the identity graph. So this is the only one that when you graph it, you actually got to plot 2 points. It won't open the box for us. So we'll grab our line tool. So let me move that over where I can see the actual problem. So I grab a line tool. And I need 2 points. So I'm going to use 0 and 1 from my x's. If x is 0, 0 minus 2 gives me a -2. So my first point will be 0, -2. Click that. And then if I make x1, that'll be 1 minus 2. So 1 minus 2 would give me a -1. So at 1, I'm at -1. Click that. So plot 2 points on this one so that it'll actually draw the line for you. Save it, and then you'll have to check the answer to move on to the next one. All right, so let's see what this is doing. They're giving us h of x equals 1 over x minus 5. So that was, I think, the 6th graph on that sheet I gave you. So they're telling you it started from the graph f of x equals 1 over x. So what we need to do is figure out what that -5 did to my graph.
Down.
So yeah, it's going down. It's not attacking the x because the x is on the bottom of that denominator. So you on this one, you just click C, shift it 5 units down, check our answer. So y'all, would that be A, B, or C? And I'll tell you what, A looks like the basic graph, right? A is the basic graph. So you either got B or C on that one.
B.
So B went down 5, so you click on that, and it looks like C actually went up. So we would have to pick the B, like you said. Check that, and then you're moving on. Oh, so let's see what's happening here. G of x equals negative x minus 9 in parentheses cubed. Now, look down here at these answers. We can automatically eliminate B and D. Because B and D say you're going to reflect it across the y-axis. None of ours are going to reflect across the y-axis. So it's either going to be A or C. So is this graph shifting right 9 units, or is it going to shift left 9 units?
Left.
Right. It's negative.
So there you go. If it's negative inside the parentheses, that actually moves it to the right. So let's see which one shed right. That would be A, it looks like. It moved it right. And the negative in the very front is what's reflecting it across the x-axis. So y'all in here in the box, we just got to tell it that this was our x to the 3rd graph. So do our x, put in our exponent 3. So that's why I say that one, when it's inside the parentheses, that one's sort of what you would think is backwards from moving, okay? But I'm going to show y'all. All right, so now we want to click our graph. So remember, the x cubed graphs are the squiggly line that says the cube tool. Click that, click anywhere on the graph. It's automatically going to put it through the center. All right, so now, what we say, we went, that was minus, so we went right 9. So take that horizontal shifter, move it right to 9. So it moved it automatically. Now, since this one reflected over the x-axis, so y'all see what the graph is doing right now. The graph is going uphill left to right, but when I reflect it over the x, it now looks like it's going downhill left to right. So save that. Let me let one in real quick. All right, then when you check your answer. All right, before I do the next one, let me pull up my calculator real quick. I want to show y'all what's really happening on them graphs. All right, so let me share this screen. All right, so y'all, I'm going to go to y equals. And I'm going to clear that off. I'm going to go down to, I don't want mine to shade, so let me go down. All right, so I'm just going to put in an x to the third graph first. So x exponent 3. So this is going to look like our basic graph when I graph it. It's going to go uphill, left to right. So now I'm going to go to y equals, and I'm going to go down one. And I'm going to do parentheses x minus 9, close parentheses, and I'm going to cube this. Now I'm going to go all the way left. I think I can make my line a different color. Let me see. So I'm going to hit enter. All right, so it might do it. Let me see. All right, I'm trying to hit okay. All right, so let me graph the new one. So the first graph is x to the third. Now remember, we're subtracting 9, so we said this should move it to the right 9 on the second graph. So you'll see how it actually moved it to the right on that second graph. If I'd have added 9, it would have moved me to the left on that second graph, okay? So I'm gonna go back and I'm gonna go down. I'm going to delete that. And then I'm going to insert what I need a positive. So now watch what happens when I add the 9 instead of subtracting. So the first graph was black, the moved graph is now the pink one to the left. Okay, so I wanted y'all to actually see that it does really move those graphs from us, okay? All righty, so we got g of x equals x plus 3 squared minus 4. So it looks like the first thing they got is start with the basic graph, f of x equals blank, shift it blank 3 units, and then shift it blank 4 units. So since you see an exponent of 2 on this, this is going to be your x squared graph. So what I need to know, when you click this arrow, it gives you 4 options: down, left, right, or up. So the 3 is inside parentheses and being added. So y'all, what's doing? Down, left, right, or up?
Left.
So it is definitely going to go left. And then how about this one? And then you're going to do something 4 units.
Down.
It's going to go down. There you go. See, this section ain't too bad, is it? So we will check that. Now we got to graph it. So click on enlarge graph. Remember, we're going to start with our x squared tool. Click anywhere, it's going to put it in the center. So we went left 3 units, so that would be horizontal. Let's put it to -3. And let me see, I got to move this to see what my n number was. That was -4, so go to your vertical shift and put it on -4. All right, so I got it on -4. See, it moved it left and down, so you save that. And then you're checking. Let me see, y'all. We've only got about 3 more of these. So let's see what y'all think about this one. F of x equals the square root of x plus 9. Now they're telling you you're starting with the basic graph of square root of x. So what do I need? By adding 9 under that radical, right, up, left, or down.
Right?
Oh, I got y'all, didn't I? Because remember, when it's under this radical, you gotta treat it like it's in parentheses. So when you add it to those x's in the parentheses, remember, when you add 9, it's actually moving it to the
Right.
no.
I said it right.
Down.
No.
So that would actually be left, and then you would put in 9 for the units. Okay, so treat this like parentheses. For me to go up or down, my +9 would have had to be outside the parentheses. So y'all, let me show you on that calculator real quick the difference. So calculator, I'm gonna clear this. All right, so square root, watch this, I'm gonna hit second, x squared to get my square root. And I'm gonna do it. X plus 9. So see, the x plus 9 is under that radical. Watch when I graph it. It started in the center, but when I added 9, it moved it to the left 9 units. Now, it all depends where you put that +9. So let me go down. I'm going to delete the plus. I'm going to delete the 9. And I'm going to go outside. Notice I'm not under that radical no more. So I'm going to go outside and add my 9. So watch the difference. Inside it moved it left 9. When I put it outside and hit graph, whoo, you can barely see it. But if you notice on the top, that graph is starting way up there at 9 on that y-axis now. So let me make my number a little smaller than 9. So let me make that 9 a 3 so you can see better. All right, so if I make it a 3, it's outside the parentheses. See, it moved it up 3 actually, okay? So what's fun is you can actually graph these on the calculator and actually see what happens. All right, so let's see, A, B, C, or D. Which one of them went left 9 units?
See?
And guess what? You check that answer and move on. All right, let's see what's next. All right, they're saying, how can the graph of g of x equals cube root of x minus 4 be obtained from the graph of f of x equals cube root of x? So y'all, is that minus 4 moving me right, up, left, or down?
Down.
It's definitely going to be down because it's not up under that radical. Now, had it been up under the radical, it would have been a different story. But remember, they took the function and then added or subtracted. So that moved me down. So let's see. We got to graph this one. Yeah, we got to graph it. So what are y'all picking? A, B, or C? And I will say this, B looks like the basic graph. B is what it is when it's just a cube root of x.
C.
So it's gonna be C, that would move down, so we would put C, and then check our answer. All right, so we got one more to do, and then I'm gonna review y'all a little bit, just to get you ready for my Wednesday stuff. So on this one, I would go, I would do the parentheses first. Then I would get the reflection, and then I would see what that +6 is doing. So this first box, when I click it, that looks like they're doing left and right moves. The only way to move me left or right is inside those parentheses. So since that 2 is being subtracted, am I moving left 2, left 6, or right 2?
Right 2.
I'm gonna move right 2. Good job, because remember, the left and right is inside the parentheses. Then we're gonna reflect it across the, what are y'all putting here?
X-axis.
X-axis.
Yep, that can only be the only answer y'all can put on that, okay? So all that's left is what that +6 is doing at the end of my graph. Up 6, down 2, down 6, up 2.
Is it down 6?
Are y'all gonna go with that?
No, you didn't let me finish. Up 6.
Up 6. So remember, those numbers added at the end, they actually literally go up or down like you would think. The only one to me that's backwards is that stuff inside them parentheses. So y'all, let's check this, and then I'm gonna do a similar one for y'all to knock out. I want to hit similar question. All right, y'all, here you go. Same graph, negative x minus 4 squared plus 6. So left 4, left 6, right 6, right 4.
It's gonna go right 4.
All right, then reflect it across the,
X-axis.
and then we want to shift it up 6, down 4, down 6, up 4.
Up 6.
And there you go, y'all. Then you would check that answer and be done. So I think that's the last one. I did it twice, number 8. So that was it on those. So we're going to go and start reviewing for another type of formula. So y'all, that homework's not bad. Just keep up with those basic graphs and those 3 moves we did, okay? So y'all, let's see. This will be a review, or we're actually going to learn this, but I'm just going to see what y'all know so far. I'm going to put a formula down here, negative b plus or minus square root b squared minus 4ac all over 2 times a. And I'm going to explain how we get this plus or minus stuff on this formula. But do y'all know what this is called? Oh no, some of y'all should have hit this. Y'all must all be a little older like me, right? All right, so here we go. This is what we call the quadratic formula. In a quadratic formula, we'll solve any equation in the form of ax squared plus bx plus c equals 0. And I'm going to explain all this, how to get A, B, and C and all that fun stuff Wednesday. But to be able to do the quadratic formula, you got to be able to work this part right here under that radical. Okay, this stuff under the radical determines if I get 1 real answer, 2 real answers, or 2 imaginary type answers. Everything that controls that is under that radical. So here's a review on simplifying the radicals. So we'll start out sort of basic. That's a radical, so what's that mean? Square root of 9, what's that answer?
Three.
3 cubed.
No, it'd just be a 3. So the square root finds whatever number got multiplied 2 times to get a 9. Now, there's also another answer. What other number times itself will give me a positive 9?
1.
Oh, what y'all just say?
I said 1.
Well, remember, 1 times 1 is just 1.
Oh, I'm sorry. I'm sorry.
Mhm. So positive 3 times positive 3 gave you a 9, right? What about negative 3? What's negative 3 times negative 3?
Positive 9.
Positive 9. So in reality, we can say, hey, that square root of 9, the answer is a positive or negative 3. That's where this plus and minus means. It means that I could take the square root of a number like 4. It could give me a positive 2, or the square root of 4 could give me a negative 2. Okay, so that's how you get 2 answers, is because square roots really got 2 answers, okay? So knowing that, what would y'all put for the square root of 49?
Positive and negative 7.
Okay. So numbers like this are what we call perfect squares. So it's a good thing to know some of these perfect squares. So 1, because 1 has the square root of 1. 4, because it has the square root of 2. 9 has the square root of 3. And I'm just going to start writing all these perfect squares. I'm just going to go up to 15. So these are all the perfect squares. Square root of 4 is plus or minus 2, plus or minus 3, all the way down to a plus or minus 15. So let me show you why you want to know these. Because what if I had something like a square root of 20? Well, we don't want decimal answers. Now, if you punch a square root of 20 on a calculator, yeah, it's going to give you a decimal answer. But we want these answers to be what we call exact answers. So that means you still got to write them with the radicals if you can't get rid of it. So square root of 20 is not in this list. So here's my question. To simplify this radical, I have to remove any factors of these numbers that are perfect squares. So y'all, here's my 20. Other than 1, because 1 ain't helping me do nothing, right? Out of these other numbers, are there any numbers that are factors of the 20?
4.
So since 4 is a factor, we would write this as a square root of 4 times a square root of 5. Now, under the radical, 4 times 5 still equals 20, but we're doing what we call the product rule. We're splitting it into products. So now the reason we did that, we now know what the square root of 4 is, right?
You're right. 2.
So plus or minus 2. We can't do nothing to the square root of 5. 5 doesn't have any more factors that are perfect squares. So that would simplify to a 2 square root of 5. So I'm going to let y'all have one here. How about Square root of 28. It's not a perfect square because it's not in my list.
Is it plus or minus 2 to the square root of 7?
Oh, cool, because you did what, 4
Yeah, it's 7.
and 7? So then that gave me a plus or minus. Square root of 4 is 2. And then my square root of 7. Good job, that's pretty quick. So let me throw y'all another one. How about a square root of 27?
It's plus or minus 3 to the square root of 3, right?
Yeah, because I would make that a
Okay.
9 and a 3. And square root of 9 is your plus or minus 3. Square root of 3. Well, these are fun, ain't they? Y'all should be pretty good.
Maybe it might be a little bit fun. Yeah. Okay.
How about that? Square root of 31.
It's not on your list of perfect squares, so wouldn't it just be square root of 31?
That's it.
Okay.
So if it don't simplify, we leave it the same. So there you go. So that one does not simplify. So these answers are all what we call real numbers, real answers. So I'm going to change the game up. And I'm going to do a square root of a -9. So y'all check this out. There's no number times itself that'll give me a negative answer. Right? 3 times 3 is 9. -3 times -3 is 9. So what we did, they wanted to still be able to simplify this. So they said, well, let's let square root of -1 equal I. This is how you get imaginary numbers. So notice what I got. It's almost like a constant. Square root of -1, whenever I get that, I'm going to replace that with the I. So this little radical now, I can separate it with my 9 times the square root of -1. So I'm breaking out that square root of -1. So now, square root of 9 plus or minus 3. Y'all, we still can't take the square root of -1, but we're going to replace it with a I. So the square root of -9 in the long run is a 3i. Okay. And y'all, I'll tell you what, I times I is I squared, and I squared equals -1. So when you do 3i times 3i, you got 9i squared, which is -9. So it will work back with imaginary numbers. So now that y'all know what I did here, what is the square root of a -25?
Wasn't it plus or minus 5 to letter I?
Amen. Plus minus 5i. Square root of -81.
Square root of 3.
Oh,
3.
I heard something, but it buzzed down.
Plus or minus 9i.
So y'all, that's where imaginary numbers come from. Imaginary numbers are only numbers that I get when I try to take square roots of a negative number, okay? All right, so remember that for a second, because I want to switch up. And how about this? Square root of a -45. So simplify the square root of 45, but also remember, you got that negative under there, okay? So when I get something like this, I make 3 radicals. And I always put my -1 in the middle.
Yeah, and you got 5 and 9.
5 and 9.
So plus or minus 3 to the square root of 5i.
Mhm.
Oh man.
Now, you can put it in that order. I sort of put my I in the middle. That way you don't accidentally put it under the radical with the 5. So sometimes if you do this, some people write it and they accidentally get it under that radical. If it ends up under the radical, MATLAB will mark them wrong, okay?
Let me ask you a different way. If I was in another professor's class, how should I write it?
Oh, I would probably say like that.
Okay, cool. Thank you.
Yeah. All that real stuff out front, the imaginary I, and then we'll put the radical with the square root of 5 last, okay?
How does MATLAB take it?
Oh, it should take it. It'll take it either way. But just be careful when you do that. Make sure you arrow out of that radical before you put that I, okay? It'll take it either way. But yeah, once you put your 5 in, you got to arrow out with that little arrow button and then put that I. It'll take that. But if you don't arrow out and it looks like that I is up under it like I did there, then it's going to mark that wrong, okay? So usually in math, we tell y'all to put it in this form, the number, the I, then the radical. That way you won't accidentally make the mistake and put it under there. Yeah, I could actually do it like this. I could do square root of 5, 3i, as long as my 3 and the I ain't under that radical, okay? All righty, let's see. How about a square root of a negative? Oh, how about 75? Now, does that one simplify?
Well, then isn't that
Square root of 3.
15? No, not 15. No, I'm wrong.
Wouldn't it be 25 times 3?
So I would make that a 25, and then my -1, and then my 3. Good job.
So it'd be 5i to the -3. I mean, 5i plus or minus 5i square root of 3.
There you go. There you go. There you go. Now, usually if they end in a 5 or 0, I'm looking at 25 being one of my factors, okay? Because some of these, well, 45 had a 9 and a 5, but a lot of these bigger numbers, I'm going to look at numbers like 25 and stuff. All righty, so I'm going to show y'all one more example of me actually working that quadratic formula to solve an equation. So I'm going to use it to solve x squared plus 14x plus 45 equals 0. Now, I'm not going to lie, you could factor this one to solve it, but a lot of people don't like factoring, and this quadratic formula will solve every single one of these quadratic equations, okay? So we just got to figure out what our 3 numbers are going to be, because remember, I'm using my quadratic formula, negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So the first thing we got is our negative. Now, we got to figure out what a, b, and c. A is in front of the x squared, b is always in front of the x, c is always the last number at the end. They got to be in descending order from exponents to the x to the number. So I'll put it this way. B is 14. C.
A is 1.
A is 1. There you go. And then C would be my
45.
45. So you already got the trick. If there's not a number in front of that x squared, y'all, it has to be a 1. So here's our formula. Bring down that negative. Put in b. B was 14. So all that negative does is change the sign of b. B was positive. That negative is going to make it negative. Then we got plus or minus square root. B would be 14 squared. Now, you don't necessarily have to use parentheses around a positive number. But if that was a negative 14 I was putting in there, you better put it in parentheses before you square it, okay? Because anything you square will become positive. All right, y'all, then it's what? Minus 4 times A, which is 1, times C, which is 45, all over 2 times 1. Now, I'm not gonna lie, most of my work is gonna be sitting under this little radical. Because that negative in that 14, just gonna make that a negative 14, plus or minus. So 14 squared,
196.
196. Now, all this is getting multiplied, and there's only one negative on that side, so that's going to stay negative. And then 4 times 1 is 4 times 45. Oh, that's what, 90 times 2, so that'd be 180. All over the bottom, 2 times 1, which is 2. So you can't do nothing with these numbers on the outside until we get this radical all the way simplified. So bring down to negative 14, plus or minus 196 minus 180. That's what,
16.
16, all over 2. All right, y'all, so I'm gonna bring that up in here now. So that's gonna equal negative 14 plus or minus. So what is the square root of 6?
4.
That's gonna be a 4 all over 2. So I got 3 numbers there. If I'm going to be able to simplify this further, all 3 of these numbers will divide by what?
2.
So I got to divide everybody by 2. So negative 14 divided by 2 gives me a negative 7, plus or minus 4 divided by 2 is 2. This will now give me my 2 answers. We'll figure out our first answer and then our second answer. And y'all, a little trick, the exponent always tells us how many answers we're going to get. So since I got an exponent of 2, all these will have 2 answers. Now, sometimes it's a repeating answer, but they got to have 2 answers, okay? All righty, to get the first answer, negative 7 plus 2.
Negative 5.
Negative 5. To get my second answer, you're going to go negative 7 minus 2.
Negative 9.
There you go. And that negative 9 and negative 5 will multiply to give you a positive 45, okay? So that's the trick. Now, we will look at some on Wednesday where the radicals don't simplify all the way into numbers. So we'll write them answers using that plus or minus. So what I mean is, say I worked out one and I got it down to my final answer and I ended up with something like 5 plus or minus square root of 3. MathLab will let me write in the answer like this, because you can't add radicals and whole numbers, okay? So these are not like terms, so we can't add them like we did up here. So instead of me having to write 5 plus square root of 3 and then 5 minus square root of 3, MathLab will actually give us that button or that tab choice so that we can write it like that, okay? So knockout 7.2. I think we went through all 8 of them problems. And then Wednesday, we're going to do 7.4 and 4.8. And they're all working with this quadratic formula, okay? All right, y'all. So let me go to my main screen so I can see if I got everybody in here. So, all right, so I got all of y'all on that. So, y'all, do y'all have any questions over that 7.2?
No, sir.
No, that was kind of fun, actually. I like the square roots and the radicals. That was
Oh
it was
yeah,
kind of fun. It
so
was like a puzzle, actually. It's kind
yeah.
of fun.
So y'all gonna get to play with that Wednesday. So how about the graphing? Are y'all good on the graphing?
Gonna
Vertical
need to watch the
shift.
video again.
We'll have the vertical shift, horizontal shift, and reflections and what y'all gotta worry about tonight, okay? All righty, so I'm gonna stop this recording.